Okay, hello everyone, it's Salar, and this is part 48 of our tutorial writing a real-time operating system. In previous part, I described SVC handler and kernel system call handler, but I had a little problem in implementation of this function, but now I resolved that. Let's just see what was that problem. In RTOS source kernel C, in kernel system call handler, in this function. Okay, in this function, when you read an argument from system call list after sending this argument to the kernel system call by number to this function, you must replace it by null. Okay, and after servicing all of system calls, you must reinitialize the index to 0. Okay, it's a problem, and I resolved this problem. Okay, but let's go back to the slides and start another part. But as I said in previous part, in this part I want to talk about kernel space system call. Kernel space system call of thread create new. Okay, thread create new, and this suffix. Okay, this suffix shows this is a kernel space system call. But as I said in previous parts, when you want to get a service from RTOS or operating system, you need to call a system call. By using of user space system call, you collect all of arguments in a specific struct, put address of that struct in addition of by a system call number to a global struct, and send the global struct to the kernel system call. Okay, kernel system call, put the argument in system call list. After that, this function call kernel system call request set a member. Okay, and call SVC. In SVC handler checks if you have a system call request, call kernel system call handler, and after calling SVC 0, this instruction, you enter the RTOS enter to kernel space, and by using of kernel system call handler, read argument and request from system call list, and by using of system call number, call a kernel space. Kernel space system call. Okay, at this part I want to talk about the last stage, kernel space system call. But before talking about this function, let's see another time this structure of ready list. I said ready list is an array of pointers. Okay, and each pointer point to a circular queue. Okay, each pointer point to a circular queue. But before to talking about kernel space system call, we must first initialize and make this structure for RTOS. Okay, but another time let's see kernel control block. In kernel control block there is a member ready list. It's an array, and Length of array is number of priority. Okay, and this is ready list structure, array of ready list. Okay, this is this array, number of priority. Okay, and for each elements of this array, RTOS must create a circular queue. Let's see the code. You can see in the vintage project RTOS include RTOS type definitions. Kernel control block, you can see ready list. Okay, this is the ready list of RTOS. Okay, and kernel initialize function initialize the ready list. Let's see kernel initialize. Kernel initialize here by using of this function by using of this function. Okay, by using of this function, RTOS initialize this list. Okay, initialize this structure. But before to talking about this function and inspecting this function, I must say all of data structures in our RTOS called list. List doesn't mean just circular list or single linked list. Okay, in the RTOS, even a binary tree is a list. Okay, all of data structures called list and will call list in the RTOS, and all of data structures functions, those functions that by means of them you can manipulate data structures, implemented in list.c. Okay, you can see here there is a list.h and there is a list.c file. You can see in list.h I have some functions to create ready list, create a node for ready list, insert to ready list, delete from ready list, get first, and other functions. Okay, and for example, when you create a ready list, this function create a circular queue. Okay, so for each of these priorities you must create a ready list, a circular queue. Okay, here, so in kernel.c, in this function kernel ready list initialize, you can see for each of priorities, operating system create a new ready list and put address of each circular queues in kernel.readylist in this array. Okay, so in kernel initialize, RTOS create this structure. But now let's talk about thread create new system calls, this function. Like simple RTOS. Okay, in previous parts I developed a simple RTOS. Okay, like simple RTOS, this function first initialize thread control block. Okay, like simple RTOS, for each thread you have a thread control block. some information about a thread, ID of thread. At this time, ID is not an integer number. ID is a address and pointer that points to address of a thread control block. Okay, each thread has a name, has a state. Okay, at this time ready or running, but I will add other states to the RTOS. Function parameter, I will talk about function parameter in next parts. Function pointer, each thread you remember from simple RTOS, each thread needs a function. Okay, for example, thread 1 add thread function 1, if thread. Okay, and RTOS run this thread. Here each thread needs to have a priority, a stack size, stack top, and current stack pointer. Okay, and a ready node. You can see ready node is a circular queue node. When you want to insert a thread to one of these queues, circular queues, first you must create a node from that thread to insert thread to circular queue. Okay, so each thread needs to have a ready node, and by using this function list create new node, RTOS create a circular queue node for that thread. Okay, so let's just see the kernel space system call thread create new system call. This suffix shows this function is a kernel space system call. So first you must allocate memory for thread control block. You must allocate memory for this data structure. After that, put address of this data structure new thread to the thread ID, and put this value in thread ID. Put this value in ID. So ID is the address of thread control block, and you must initialize the name of thread by using this code. Okay, after that you must initialize a state of thread to the ready, because you want to insert thread to the ready list, one of these circular queue according to the priority. Okay, so initialize the state is thread ready. You must initialize function pointer and function parameter. As you can see, arg, this arg is address of this structure, a specific structure. As you can see, the type of arg is thread create new args, and type of thread create new arg is thread create new arg. Okay, arg is the pointer to this structure, and in this data structure you have these arguments: name, function pointer, function parameter, and others. For example, when you want to initialize function pointer in thread control block, use arg thread function pointer arg. Okay, this value, okay, and this argument, and this value is this argument. After that, set the priority of thread according to the arguments of user space system call. Okay, for example, for this thread is priority normal, thread 1 is priority normal, and thread 2 is priority normal 2. Okay, by using of this argument, initialize priority. After that, initialize stack. Okay, initialize stack. I described stack initialization in simple RTOS. Okay, refer to simple RTOS parts, and in those parts I completely described stack initialization. Another time, as you can see, in port.c define stack initialization. Do these works. Okay, refer to simple RTOS. Refer to this project simple RTOS that I've developed in previous parts. Okay, I completely described initialization of the stack. But as you can see, I have put thread function parameter, this value in thread stack top minus 32. This is address of register 0 or 0 in the stack. Okay, you know, for example, stack top minus 8 is address of link register in stack. Okay, but stack top minus 32 is address of register 0 in stack. Okay, and when you put this value in register 0 before jumping to this function, so you have this value in this argument, because as I said, according ARM architecture procedural call standard, when a function have an integer argument, the value of this argument has been located in register R0. Okay, because of that you must put this value parameter to this address in a stack of thread. After that, create a ready node. By create a circular queue node. Okay, and put address of this node here. And by using of this node, RTOS can put a thread in a ready list. Okay, after, if initialization has no problem, insert thread to the ready list. Insert the thread to the ready list by using of this function. As you can see, this function defined in list.c. And enqueue the thread to the circular queue according to priority. In kernel, insert in kernel.readyList according to priority of the thread. Okay, put to one of these circular queues according to the priority. If priority is normal, put this circular queue. If is ISR, put to this circular queue. Okay, so this function does these works: thread control block initialization, thread stack initialization, I've completely described stack initialization in simple RTOS parts. Okay, put thread to the ready list according to the priority. Okay, and request for context switch if it's necessary. By using up this code. After inserting a new thread to ready list, call this function. This function first check if kernel state is running. After calling RTOS start, RTOS change the state of kernel to the running, okay, after calling this function. So if RTOS has been started, okay, and if priority of new thread is greater than priority of running thread, okay, if kernel is running and priority of new thread is greater than priority of running thread, now RTOS do a context switch, RTOS do a context switch, request for a context switch, and RTOS will run the thread with higher priority. Okay, to request a context switch, this function do some works, and I will describe this function in next part. Okay, so for example, in this example, priority of thread 1 and thread 2 is normal, but if, for example here, if at this point I create a new thread with higher priority than normal, after creating thread, RTOS immediately jump to that thread. For example, assume we have another thread, thread ID 3. Okay, and for this function thread we have the function, and the function is here. If, for example, at this point you create a new thread with higher priority, for example priority high, after calling this system call immediately, let's to put it here. After calling this function in thread function 2, RTOS immediately jump to thread function 3. So let's do debug this example. Okay, let's do another time inspect system call process. Jump to user space system call, and if all of arguments are okay, jump to kernel system call. By using of this function, put the argument in system call list and call kernel system call request. Set a variable by using of this function, set the member, system call member, and call SVC. In SVC handler here. check for system call request. If system call has been requested, jump to this label and call kernel system call handler. And by using of this function, read argument from system call list. Read the argument. If the value of argument is not null, call kernel system call line number. And by using a system call number, run one of kernel space system calls. And now thread create new system call, kernel space system call. First, allocate memory to thread control block and put this address here. New thread, put this address 9D8 to the ID. Okay, now in thread, here is a new thread is thread control block. The value of ID is 9D8, address of thread control block, address of thread control block. Okay, after that initialize the name. Okay, initialize the name. Let's close this. After that, initialize state. Function pointer, function parameter, priority. Initialize stack size, stack. And create a ready node. And if node has been created, put this value, put this address in thread control block and this member. And if all of initialization is okay, check if after that insert thread to the ready list. Let's run this function. You can see now thread priority is normal. Okay, and according this priority, put to one of these circular queues. Okay, and return from this function and check for context switch. Okay, for example here, because kernel state is not running, kernel state is initialized. Okay, the RTOS, this function doesn't request a context switch, and after that return from these functions to the return from all of functions. For example, return from system call handler, reinitialize this value to 0, return from SVC, return from SVC, return from kernel system call, and now return to thread create new, and thread has been created at this time, and return value is address of thread, is a thread ID, return value is thread ID. Another time 9D8, ID of thread 1. Okay, and return from this function. Now thread 1 has been created, and if you create thread 2, and after that run RTOS start, RTOS jump to thread function 1. After 1 millisecond, jump to thread function 2. Here you can see in kernel.c here in this variable kernel control block. Now the tick is 1. Okay, at tick 0 the RTOS run thread function 1. Now in tick 1 after 1 millisecond, now RTOS is running thread function 2. But if you create thread 3 with higher priority, because current priority is normal, thread 2 is normal, and kernel is running. Okay, let's see this function, check for a system call after insert. Because kernel state is running, and kernel state is running and thread priority is greater than current priority at this time, immediately RTOS jump to thread function 3. You can see immediately jump to thread function 3. Okay, and since this time, from this time, the RTOS always run thread 3 because it has higher priority than thread 1 and thread 2. Okay, at this time you have in normal thread 1 and thread 2, and in high you have thread 3. Another time in kernel.c, in kernel control block, and in ready list. Ready list number 3 is priority of normal. Okay, three is priority of normal and 5 is priority of 5 is high. Okay, priority high number is 5. You can see here priority levels here. Normal is 3 and high is 5. The size of circular queue number 3 is 2. Okay, because we have thread 1 and thread 2 in this ready list, but the size of 5 is 1. This is thread 3, but for example above normal priority number 4 is 0. Okay, and because thread 3 has higher priority than other threads, the operating system just run thread 3. Okay, so this was thread create new system call. Okay, by using of this function RTOS first initialization thread control block, initialize the stack of thread, put new thread to the ready list according to priority of the thread, and request for context switch if it's necessary, if kernel is running and priority of new thread is greater than current running thread priority. So very good. This was the structure of system call in the RTOS. And when you call a system call, RTOS does this process one by one, step by step. Very good and very nice. Thank you very much to see me, and see you soon in the next part. Thank you very much.